Hi, my name is Tom Harvey. I'm the engineering lead on the Azure Provider, and I'm here to talk to you today about the Typed Sdk that we have in the Azure Provider that we're making use of to build resources. So the Terraform provider for Azure makes use of the Terraform Plugin SDK, as does every other Terraform provider. And what we've done, whilst it works very well for us over the years, one of the things we've been doing recently, because we have a lot of Azure specifics, is to wrap that to be able to give us a more strongly typed experience, which means we have access to things like autocomplete and just generally reduces the amount of code that we need to use when developing resources. So before I get started, I want to call out a couple of things. The first is that the Typed SDK lives within the Azure RM provider repo. So if you go to the Terraform Azure repository, Azure RM repository, and go to Azure RM internal SDK and README, there's this README which tells you basically how this works at a high level. We have this concept called service packages in Azure. These basically map to different resource providers in Azure. So compute, networking, notification hubs or event hubs or whatever else. And we add these, as we need to. The benefit of this, it means we can split our code up quite considerably. And so if I jump over to the code base, what it means is that we can have, for example, front door is just the front door resources, which is helpful when you get to some of the larger resources like networking or compute, where there are considerably more. And this is something we're breaking up over time. It just makes it easier to move forward with those, essentially. So yeah, as I mentioned, the Typed SDK is something that we have available. What we're going to be doing today is building a resource with that. So I've created a service package here called HashiTalks. Service packages for us are located inside the repo Azure RM internal services, and then there's a list of packages. In the interest of time, I've pre-created like an empty package called HashiTalks. What we're actually going to build here is a Terraform resource to create a resource group, which we already have in the provider. But this is, a fairly simple example. But this works for any kind of resource, which is really neat. So the first thing we have when you talk about resources in Terraform is the actual resource itself. Now, if we take a look first at the actual resource group resource, if we go to resource, which is where the resource group resource is, today this is it's a generic Terraform Plugin SDK resource, right? It has create, has read, update, delete, importers, timeouts, etc., the schema, and then functions for those. And this works great. We use this all over the place in the majority of the provider. What you come to realize is that there are certain bits that are specific to Azure. For example, in Azure, we validate the ID at import time. So we know, for example, in this case, it's always going to be a resource group ID. And we know that because of the way, every resource in the Azure provider supports timeouts, so we always have timeouts. And whilst these are available in the Terraform Plugin SDK, they're optional properties today, so you have to remember to go and add whatever it is you need to add. So this works great. What we've done is extend this slightly. So we have this typed SDK, this strongly typed SDK, which basically allows us to use native Go types and the Terraform Plugin SDK together. So what do I mean by that? Well, this is the README, as I mentioned earlier. Basically, what this means is we can use the actual Go type here for a struct, and then there's methods that fall off of that. So for arguments, attributes, the resource type, how to create, read, update, delete that, etc. And there are actual typed methods, which is nice because it means, again, you can get autocomplete for these things. So if we switch over to the code, and if we go to this empty package that I have available, what that means is we have, and this is a very basic example, I have an empty struct here called resource group, and it complies with this interface called resource. Now we have three available in here of data source, resource, and resource with update. So a data source is a Terraform data source, which is just read-only, essentially, getting me information about an existing resource. There is a Terraform resource, which will create, read, and delete a resource. And there is a resource with update, which is just a resource, but with the additional update property. But yeah, so what's nice is because this is just a generic Go type, they automatically, start that again. Because this is just a generic Go type, we get autocomplete on these because the type, the struct here, resource group, resource doesn't comply with this interface right now. And so we can implement methods, and it'll give us the template, the scaffolding methods. But the nice thing about Go is you don't necessarily have to do that. If you were to comment that line out, because the resource group resource struct implements all the methods, it's automatically implementing that. So the benefit of this line for us means essentially you get autocomplete. So if we decide later on that, hey, we want to add or remove this new method signature, we can do that. Or if we decide this needs to update, for example, we can do that, go, hey, we need to add this update function, go do that. It's a minor enhancement, but it's kind of really helpful. So let me take you through these methods in turn. So essentially, arguments is the Terraform schema that is mutable. So that's all top-level objects and any items nested under them that are mutable in any fashion. So for example, the top-level name, location tags, there may be objects within that, like a virtual network would have a subnet block, for example. That will all be housed within here. Attributes is then read-only values, so computed values for us. There's not much point splitting these apart. These are split apart primarily for technical reasons. It just makes it easier when we generate the documentation later to know that, hey, we have these that are arguments and these are attributes. It's minor, but they work great. It works for now. We then have a model object, which we'll come to in a moment, or a little later on. The Terraform resource type. So this is the actual resource label itself. So Azure resource group, for example, or something to that effect. And then 3 functions. So create, read, and delete. These are all the same. These actually return this type of SDK.resourceFunc. And if you dig into that, these then return 2 fields for us. The first is a timeout. So I mentioned in the Azure Provider, everything supports a timeout by default. And so for us, this is just a way of us guaranteeing it. All right, so we can say the create should finish within 30 minutes by default, but this allows users to override them as necessary. The other one is then the function itself. So this is the create function. And this is where it differs a little bit from the plain Terraform Plugin SDK resources. So whilst we have this metadata object available, and what this basically does is wrap Terraform resource data with a couple of other things. So the first is the client that's available today in the Terraform Plugin SDK as meta, and you can cast the client and do what you need to on it. The other one is then resource data, which is like the D property in the Terraform Plugin SDK today. What this means is that you can use the Terraform Plugin SDK as you do today, completely, for free. It's here. It's get and set and all the other bits. There's also a logger and a couple of other helper entries. We'll come to those in a bit. But yeah, this means you can add warnings and info, and it's pretty convenient in that regard. Finally, we have an ID validation function. Now, in the Azure Provider, we are moving towards generating Terraform, or generating the resource IDs within Terraform. What do I mean by that? Well, we have this resource IDs function, or this resource IDs file, that uses Go generate to run a tool we have, which generates an ID parser and an ID validator for a specific resource group, or for a specific resource ID, sorry. So in this case, we're creating a resource ID parser and validator for a resource group. So we give it a name and we give it an ID. So in this case, this is just placeholder data, but these are just generated. So if we run, if we generate that line, or if you run go generate on the command line, it'll then output an ID parser for us, which will then take the, where are we? So pass resource group ID. If you pass in a resource group ID, it will pass it and validate it has all the sections, right? It has a subscription, it has a resource group element. And if it was like hypothetically a virtual machine, we check that the virtual machine segment was present, that type of thing. But there's a couple of other nice things in this. The first is that there's an ID on this. So this means that we can basically template the values out of this. So whilst we can pass it, we can also build this up at the same time. So taking the subscription ID we know and the resource group ID we know. It also means for things like errors, we can then use this descriptively there. So we can say output, we know this is a resource group. So if we fail provision, we can go, retrieving with a format string, and then that then gets translated to, resource group with all the segments inside of it. So it's much cleaner for people to read. And it also means there's much less code for us to manage within the provider, which is nice. The other thing that gives us is an ID validator. And again, both of these are generated with test and all the rest of it. But this means that inside of Terraform schema, when we reference these resources, or when we reference this inside the Terraform schema, we can validate that we're passing in a resource group ID, for example, if we're requiring a resource group. And other things to that effect, which is kind of nice. So yeah, there's that. So ultimately what that means is that we can use ultimately what that means is that import time when we're requiring the resource ID, or when we're checking the resource ID, rather than defining it on each resource itself. So to go back to the resource group, resource, you have an import over for us. That means that we validate the import, the resource ID matches what we expect as a resource group ID in this case, and then then do a Terraform import. What that means is that we can do that automatically. So if we go back to the typed resource, what we do here instead is to return the validation function. So validation.resource group ID. Make sure I pick the right package. Oh, validate, sorry. And if we import that from HashiDocs, the package, what that means is when this resource gets generated, or when this resource gets built up, we can validate at import time that the ID that's being passed in at Terraform import is actually a resource group ID. Which, yeah, is kind of nice. So what it means is we cut down the boilerplate there. So that's a typed resource. The next question is, what does this look like in practice? So what I'm going to do is to go to one I made earlier. And this is just a Terraform resource right here. And this is all the methods that you've just seen, just completed because it was quicker to type. I'm just going to add the imports because that is useful to make it compile. Yeah, and so what we have here is, again, pretty much the same resource you saw as a general Terraform Plugin SDK resource. So this is the attributes that I mentioned are mutable. In this case, this is force new for now. This isn't in the actual resource group resource, but we'll come to that in a moment. There's no computed any attributes on a resource group. It's just name, location, and tags. So there's nothing to return there. There's no model object, which again we'll come to in a moment. Resource type, we already have a resource called Azure resource group. So in this case, let's call it Azure HashiTalks demo. And then the create function, which in this case, this gets the resource group client from the Azure SDK, gets a subscription ID from the provider block, and then obtains the information the user specified in their config, so name, location, tags. We then build up the resource ID, which uses the generated parser that I mentioned earlier, So in this case, this takes the subscription ID and the name. This means that we have a consistent resource ID within Terraform, which is nice. There's some Azure specifics in here. When we're creating a resource, we check for the presence of an existing resource. And if an existing resource exists in Azure but doesn't exist in the Terraform config, or doesn't exist in the Terraform state rather, we'll require you to import it just because of the way the Azure APIs behave differently in some cases. So yeah, we do that. And then otherwise we create it, right? We normalize the location, so that is like West Europe gets translated to West Europe, just for consistency there. Do the tags, and then the creator update. As I mentioned earlier, we're reusing the string value of the resource ID type that we created, or that we generated, which means that we can cut down on the error messages here too, to just say creating this thing. And ID here is again the resource group type, which has all the stuff inside of it. Cool. So yeah, all we do in the create is to create it, set the ID, and then return nil. Inside of the thing that calls these type resources, we automatically call the read for you. So the only concern here is actually just doing the create, which is another. Like it's a way of avoiding bugs when you may accidentally call the read function of one resource from another. It's kind of nice. So you can avoid all that. So read is much the same, and delete is much the same. They're kind of standard Terraform Plugin SDK things at this point, and the ID function is the same. So as I mentioned earlier, if we have an update function here, again, we'll get autocomplete for that. I am going to add one I created earlier, which again, exactly the same as before. So that will work. That's usable in Terraform right now, and there are tests which are basically the same as the resource group to this effect, which is kind of nice. So what this does again is just its standard Terraform configuration is here's a provider block, here's the actual resource to create, go create that thing. So this is great, but the main benefit here we get is that we can reduce these d.get and these d.set calls. So this model object that I've been kind of alluding to, we can actually return an object here. So we can do, if we create a new struct called resource group model, and we add some options in this. So if you look at the schema, we have, again, name, location, and tags. And we can add a special struct tag here called tf schema for name, for location, schema. And these map one-to-one. So what this means is that we can say, these map one-to-one. So that the name inside of this struct tag here refers to the Terraform schema object. And these can also be other objects. For example, if we have a list of, subnets as an example, you can reference other objects here as well. So subnet struct as a hypothetical example with a name, tf schema, name. This then just becomes like, this is a generic Go object. So we can say there are a list of, subnets, which is then subnet, which is then tf schema, subnet as an example. And presuming that exists in the config, what that means is that we can access lists, sets, tags, and dictionaries and all the other stuff that we're able to in the Terraform Plugin SDK today as an actual Go object. So how do we do that? So if you go to the resource group model, or we take the resource group model we've just created, and if we go to the create, and if I just expand all the things, that'll make it a little bit easier. So the first thing we're going to do is to define a variable for that model, right, from the Terraform config. And then using one of the properties available on metadata, there are two methods on here of interest. There is decode and encode. In the create, what we want to do is decode the Terraform configuration. So in this case, you need to pass a pointer. And what we're going to do is decoding config. If there's an error, we'll just say there was an error decoding the config. So what that means is that we don't need to write these d.get and sets directly inside of the Terraform config. What we can do is deserialize the Terraform config into this type. And then rather than passing in, or rather than doing d.get as I mentioned, we can then do config.name in here. And config.location and config.tags. And that will work as before. And if I do the same in the read, or actually let's do the other functions then first, then we'll come to the read. The delete has no changes because it doesn't call get or set. The update does. So we'll do the same thing here. We'll do model config, sorry, resource group model. If errors not null, metadata code. Okay, so yeah, at that point we have that. Rather than then accessing tags directly, we can then call config.tags. And then finally the read. So that handles the decode, but the read is creating a new object, right? So again, there's not much that changes here, but what it means is that rather than calling d.set or metadata.resource.set, what we can do here is to do metadata.encode and then passing the actual object here. So in this case, the resource group model, and this has the three fields, right? This has the resource group name, which we pull out of the resource ID. This has the location, so location.normalize nullable, which comes from the response, which again transforms it all to lowercase and without spaces and stuff. And then finally the tags, which is then tags.flatten, and that then takes resp.tags from the response. And so what that means is that we no longer call .set with these Terraform schema names, or these Terraform schema fields all over the place. What this means is we have this actual object here, which is pretty neat. So we haven't actually seen this in action yet, so I guess that's the thing to do next. So in each service package, we have a folder, we have a file called registration.go. What this defines is either a regular plugin SDK registration, for example, this one for HSM, which either defines a list of plugin SDK data sources and resources. We call these typed and untyped just to keep them simple. In the typed case, again, I'm ensuring that this struct for the resource registration complies with what we expect. So it's, they have a name, HashiCorp, any data sources and resources. But the major difference here compared to HSM is we're not defining the actual name of the resource, the label of the resource within the registration. What we're doing is we're keeping everything encapsulated in that resource, which is kind of convenient because it means that everything, it just makes it easier. And we just define an instance of that resource here. Now, I realize there's one thing I've just missed, which is that whilst we've defined the model, the one thing we haven't done yet is the method that I've been jumping over for a while, which is this model object. So if I return an instance of that, basically a type resource is essentially just a generic Terraform Plugin SDK resource that we wrap and add some validation to and just generally try and reduce the amount of code that we need to write. But one of the things we do is by returning this object or returning nil, in which case we skip this check, what we do is we validate that all of the fields that are defined in the in this model actually exists in here. So what this means is if I put a typo in here accidentally, it'll compile correctly and everything, but it'll, when you launch the Terraform provider, it'll come up with an error and say, hey, we know you've defined name, and it's location, and it's actually, you've got a typo here. So we know there's a field missing, which is a small thing, but it's very convenient because it means at runtime of the provider, not during provisioning of a resource, you can know that the Terraform schema doesn't match. And so you get much faster feedback that way. And ultimately less code and autocomplete and all the other things I mentioned. Yeah, and I guess the final thing, because this has an update, the final thing I miss is that tags needs to become mutable. Anyway, so we're going to do two things now. So this resource is successfully built. The first thing that we're going to do is clean up the test that I did earlier. The first thing we're going to do is run the test that I mentioned earlier. So what this actually does is to, wrong file. What this actually does is to create a Terraform, or create a resource group using Terraform. So let's kick our test off. That's the first thing. The second thing is that if we then go to this Terraform config, and I'm going to create this called 99 because why not? So this is just a regular Terraform config that creates a resource group. And if we come here and we do Terraform apply, because I'm using a local development binary, actually, I guess I want to compile that. That would make sense. Don't do that. So if we compile the provider, make build or go install works. So we have the test kicking off, we have the providers compiled, and if I then go and run and try and create a resource group with that, hopefully it works. It should work. Okay. So Terraform's going to say I need to create it, is that okay? Put that yes. Cool, it's going to go create it. And if I run Terraform plan, there should be no changes. Yeah. Final thing we'll do is just add a tag just to prove the update works. Normally we would have more tests for this. At the moment, all the test is doing is just creating one of these. It's not doing any updates or anything, but that's fine for test purposes. Yeah, pools well. Apply. Yeah. Every time. Cool. If I go through and run Terraform apply for that, that'll insert one of the tags, which should then work. Cool, and that works. And our test should be complete in a moment. Tearing down a resource group can take a little while because it deletes everything inside of it. In this case, there's nothing, but it can take a minute or two to replicate on the Azure side. But yeah, so that's a typed resource. All the documentation for this is inside of the provider, or it's inside the provider repo. At this point in time, we have a few resources using it, and we're using it for some larger stuff going forward. But yeah, the nice thing is, as I mentioned, this reduces the amount of code that we need to use, reduces typos and little errors like that. And yeah, and means that we can use strongly typed things, which is kind of nice. So we're hoping to use this more going forward. And it gives us a couple of guarantees as well, specific to Azure. So for example, the context that gets passed in always has a deadline. The resource, you will always have an importer, you will always have a validate function. It's pretty nice. It's working out pretty well for us. I think we're gonna have to take my word for these tests passing, but yeah. So that's a type resource in Terraform in the Azure Provider. If you've got any questions, feel free to join. There's a Terraform Azure Slack in the README. Where are we? So feel free to join. But yeah, we're using that for resources going forward, which is kind of nice. So thanks a lot for your time. See you.